Test first, code later. Test early, test often. Tests, because guessing is for amateurs. These are the things we love to say, because tests are overlooked and underrated. The hard truth, though, is that we need to get the beam into organizations. And to get a beam into any organization, you need a good strategy. And that is what our next speaker is here to tell us. Now, this isn't Magnus Carlsen, but this is chess. This is test automation, get the beam into an organization with Magnus Sadlasvik.
Thank you. Yeah, thank you very much. Thanks. First, I would like to say I'm a Swede and not a Norwegian, as Magnus Carlsen is a Norwegian, not a Swede. It's very important. Jokes aside. Let's get started. So, this is me, Magnus. I run Autobeat, and I run Funkprog Sweden. Autobeat is focused on FP. We have offices in Stockholm and in Ho Chi Minh City, and we're looking into expanding into America also. Funkprog Sweden, it's an online meetup where we explore functional programming. If you're interested in that, just Google away, you'll find it immediately. I worked with test automation, Erlang, and Common Test for more than 10 years. Currently, I work at clients as test lead, product owner, what more? Product owner, test lead, team lead, etc., in different leading roles. Yes. So I'm just going to have one slide on why you should test, and then I'm not going to talk about that anymore. So why should you test? You should test so you don't fail in production. This is a very famous picture. Some of you might know this. This is a very famous picture. It's called the Flippin' Elk. Mercedes-Benz wanted to demo and show the world. They built a new car. They took it out on the test drive. First drive, the complete world is there looking. They make a quick turn and they flip the car upside down. It's known as the flipping elk. This is why you should test, really. Yeah. You don't want to fail here. Right, and also today I think we have heard two talks today also. One was like detective hat, investigating production issues. I say test instead of investigating production issues. It's much better than to go into production issues. Also, there was the keynote from Sean, like designing LLM native systems. As more code will be generated, this will happen because it will be sold to the management team, trust me. Someone will come with the system and say, your coders will be 100% more effective. They can output twice the amount of code. Yes, it will be unit tested. We promise with our new AI, LLM model, super duper, whatnot. Test will be even more important to verify it will actually work as promised, not just a shitload of code delivering some hacky features that works on and off. Okay. Let's go over to the main topic of today then. Why test automation is a good way to beam the beam into an organization. I thought that was funny. Maybe funny. So, agenda. First I will tell a story. And then what system benefits the most from the beam and common test. And I'll also do one example of when it's been done. We came into an organization with the beam. And then in the end, I'll wrap it up with some summary and some wise words, or so I hope. First story, this is my compilation of 20 years working in dev. And this is kind of what I constantly hear when I come as a team lead, test lead, product owner, scrum master, whatever. I come to different teams and I talk to them, and it looks like this. Everyone is frustrated, and I ask, hey, how's it going? We don't have time. We're debugging a null pointer. This is the typical, it's a little bit jokey, of course, maybe exaggerated, but this is like the typical, everyone's up in ears, up in arms, debugging. I usually ask, like, maybe we should try a new approach. No, we don't have time. That's just like, we don't have time, go away, stop bugging us. We are debugging, as you can see. Okay, so then do you have CI? No? So you don't know when the fault was introduced, because this is what you can ask people, like, which maybe you can roll back, go back in Git and just like, do you know when the fault was introduced? We do, it worked before. And when before was usually some arbitrary time, which we don't know, and which we can't roll back, because we usually rolled something out with databases and whatnot also. So why not? Then you ask, like, do you have tests? We had tests. We had a tester. They don't have tests, they have testers. However, then we run short on budget, and so you don't have tests. So that's kind of the conclusion. They run out of budget. They needed to get rid of something, someone, they cut the tester. So we don't test. No, because they don't have time to test. So they don't have a tester, this kind of, yeah. You see the wheel here, yeah. Then I usually say this, how about I do test automation? Sure. Do you know how complicated this is? It's very hard. It's impossible. No, I don't know how complicated it is, because I usually just came. So then, good luck. The team is usually, oh, finally, the guy leaves. Wish him good luck. We will never see this guy again, because it's impossible. 1 week later. Check this out. So we come to the team and just, hey, check this out. What? We don't have time. We're debugging a new null pointer. Why not? I mean, it's fun to debug null pointers, right? You have a CI with automated tests. What? Only a week and test automation works? This seems unbelievable, but it's very believable. You can take common test if you like, or you can just take any test framework, and you will probably do it in 24 hours if needed to get one test case working usually. It's not that complicated. Okay, so what can we conclude from this short story? Test is an area which is underserved, not valued. Test automation even more so, especially when you start looking at end-to-end test and functional testing and system test or complicated test. And why should we focus on end-to-end test? It's obvious, because the users are working with our systems end-to-end, not the unit test or the component or parts of the system. Test is usually get it done. There's usually, at least from my experience, no preferences or corporate policies on what should be used, when it should be used, how it should be used. It's more or less, get it done, we just need it done, please help us. And my experience with the Beam, you are very productive. I'm comparing this from my own experience, where when I worked before, I worked with C, Java, C#, etc. And with the Beam, you're much more productive. Hence, test automation is a way to get your favorite tool into an organization. All organizations? Maybe not all organizations should use and test the Beam. So which organizations should use? Is the Beam suitable to do testing for? And that, of course, goes together with what systems benefits the most from the Beam and Common Test. I'm just going to run this through quickly, but I think the first one is an obvious one. Telecommunication systems. I don't think I need to dwell on that too much. Erlang came from telecom. It's obvious that Erlang is suitable to test telecom. Messaging and event processing systems, of course, message brokers, any real-time thing. Chat systems, notification systems. Distributed databases, of course, suitable to test with Erlang or with Elixir or Common Test in general. Microservices and APIs is super good to actually test, especially asynchronous massive load test if you want to do that. It's quite simple to spawn and to keep control over thousands of processes doing simultaneously calling to one API, for example. Blockchain, I don't need to say anything. There are already people working within blockchain and Erlang. Streaming processing engines, again, pushing a massive amount of data, telemetry or financial tick data, for example. IoT platforms, Nerves is already doing it. We have high-performance web backends, of course, as I said. It's very easy. I've done it myself. We built a load. We broke a node once with just one simple Linux machine and OTP. This was not using Common Test. It's quite simple to spawn and just do dirty stuff, like a DDoS attack with one Linux machine, one Ethernet card. It's not that complicated. Fault-tolerant cloud systems, also suitable. The common denominator for all these systems is highly available, distributed, and fault-tolerant computing. That's when you should use the Beam and Common Test to run and do testing. Now we'll go to a real-world example. So this is me. I'm coming out as a team lead. The customer says, we just need to automate test. We just need to get it done. We don't care how it's done. We just need to do it. We realized we can't continue. We can't continue have a linear progress of more and more testers because it's not like going to scale. We just need more test automation. And we cannot test all the variants and all the things we are doing currently. We just need to start automating. And this is also in an era when automation was started. So it was like a buzzword. Let's automate everything that we can for some particular reason. So if you look at the background of the system, it's a legacy telecom system that has existed for over 10 years when we came in. It's hardware and software, and it's written in C. It also had a lot of variants of hardware, meaning the same software run on different hardware, but you had to test all the hardware with all the software variants to make sure everything worked. Also, as always in big organizations and software that's been around for a while, it had been sliced and managed in several different ways, in several different management structures, several different ideas of how this software and hardware should be managed. And you have a huge install base, meaning, as I mentioned, if you have multiple variants of the hardware, but you have the same software running on that hardware, you have to test on all the hardware, not to verify that the software works on just one variant, but on all variants. Otherwise, you don't really know if the software works. That's the reality. Yes. Now let's look at the initial test environments. When we came in, we had two semi-automated test environments. One was written in C, very efficient, but very much code because it was written in C. One was written in Ruby, which was not at all suiting for this telecom system at all, but it was easy to produce a shitload of tests. There was also a lot of scripts that just were laying around that nobody really knew which script was supposed to work and not to work, and when it was supposed to work and which to use at what point. There were no CI, daily, nightly build tests. Someone ordered someone to build and then test. Yeah, this is kind of dinosaur time. Yeah, and not enough coverage either, as I mentioned. You couldn't test all hardware. It was just impossible. You had to select someone. You had a strategy that for first release, we test on this hardware. On second release, we test on this hardware. And we hope that we catch the faults before downstream hits the fan, more or less. Yeah. So what did we do? First iteration. We set up Jenkins, of course. I mean, this is basic stuff. We introduced Common Test also, the Beam. Again, nobody said anything. It was more like, get it done, we need this tested. So we just said, we work with Erlang and the Common Test, so we just used it. They were like, yeah, sure, do whatever you like, get it work. We also introduced a proprietary test tool to generate test specs from Common Test comments. This is a side note, but if you work a lot with tests, you usually end up having test specs in a separate document than the actual test code. Don't do that, because in the end, you will have a test spec that doesn't match what the test code actually do, because testers are, as developers, lazy, so they will update the test, but not the spec, and at some point the spec and the code is not the same. Yeah. Have the code test specs in the code. This took around 3 months to get in place. And also the reason it took some time was that we had to automate the build. And also we had to get like a unified, or what do you call it, standardized hardware setup in place. Usually when you have hardware in the loop, you don't have a standardized way of setting up hardware. Each tester usually have one way of setting up their own hardware, meaning you can't test automate because you don't have a standard setup. So you don't even know if you come into a place, no, this is his workplace. You don't know where the laptop is. You don't know anything. So you have to set up everything from scratch. So usually step one when you do test automation, even of software, is that you have to define the hardware to set it up to work with. And this takes time because it's politics. First outcome, CI is possible. This is amazing, right? But also one person is super happy. That's the project manager. Because all of a sudden the project manager can start the test. He can initiate the test run. The project manager was initially against this because this was not his idea to do test automation. This was the line management idea. And he was just, why are you taking my money away from me to give to these people? But now he's super happy. He's like, oh, I can start on a Saturday if I like. Yeah, you can start at any time of the day that you want to do a test run. Ooh, this is amazing. So right now we have 2 test frameworks plus common test running. So Jenkins trigger common test then triggers the 2 other test frameworks. And we can now collect all the test data up to one place in one single page, which is also, of course, important because all of a sudden you can get some kind of overview of the result and the quality you have in the node. Second iteration. We wrote new tests in common test. This was Erlang back then. And we added more hardware variants to increase the coverage. And we were also able to, as we wrote more tests, we were also able to increase the coverage. Because we wrote more tests and added more hardware, we naturally increased the coverage, which increased the coverage. So what was the outcome of the second iteration? Well, we got much better control of the test as the nature of the system. We also, because you actually know when you get a response back, you can measure response time. This was an asynchronous system, so you sent a signal to it, and at some point it returned okay. But when is the time like okay, not okay, meaning if it responds okay within 3 seconds, is that within the acceptable time frame? Or has the tester just added delay infinite and wait? Who knows? You could start actually getting control of what you're testing, and okay, we know that the system will come up within this, it will respond okay within this time frame. We increased the coverage of the software plus hardware, which just in itself created better quality. Yeah. Third iteration, Beam adoption starts among testers and also developers, because they were mostly C developers, but writing Erlang code is not that complicated if you are a developer. There were Ruby people that written tests in Ruby. They were quite easy to just flip over to Erlang, especially if you write test, because test code usually isn't that complicated. And if you do easy test, you can start gradually adopting. So the third outcome, Ruby is swapped out. Simplified, yeah. We simplified the tech stack quite extensively. We could just get rid of that altogether. We could get rid of C partly, but not from what was called as the white box test. As we were testing hardware, it's hard to test hardware failures. You usually have some dirty C code that will trigger like the memory is not available or some other shenanigan that you wanted to test. So you put that on the target, and then you trigger it with some signal, and then you could simulate like hardware failures, fan failures, all sorts of failures, network failures, whatnot. Also, finally, we have real-time results. Someone could check in code. You can build, you can deploy, you can test. Sounds like basics, but it's like amazing stuff. The final outcome, the organization chose Erlang to be part of their next application. They did not, of course, this was a hardware, software, And part of the software had to be written in C because it's DSPs and stuff. You cannot write this in any high-level language. But the major controlling part were written in Erlang. So what can we conclude from this? Test this, get it done. Just get it done. People, managers tend to not care. Beam and CT is a way to unify these different test frameworks and scripts. This has been done, it can be done again. Once in place, you can start swapping out and moving over people, dependent on project, dependent on what like the goals are, of course. And also, with the Beam, you're very productive. I think swapping test cases from Ruby to Beam, 2-3 weeks for an experienced developer to do it, and you could just get rid of a complete tech stack. Yes, so if you want to spread the Beam, what should you look for if you want to do this again? One is legacy systems, and there are a lot of legacy systems out there. Majority of software is legacy system. Of course, you should then look for highly available, distributed, fault-tolerant systems. Where there's no test automation, believe it or not, most of systems have very little test automations. Or there's a lot of different test automation tool frameworks, and this comes back to usually there's no corporate policy, it's more or less the tester that decides the test tool, or this tester knows this test tool, so we had to go with that. Yeah. And of course, last but not least, I would say also tech fit and culture fit. If you're testing a BI report, maybe the best test tool is not Common Test and Beam. Maybe you should use something else. So don't push it where it's impossible. So look at the possibilities. I just took out the numbers of general Beam adoption in the world. If we look out in the wild, 3% of all developers use the Beam. According to, if you look at this, you can check out the link in the bottom. It's maybe even less. If you look at legacy system that's already been written, it's probably even less of the total systems are written with some kind of Beam technology. So the potential is enormous. There are infinite, more or less, not infinite, but close to infinite amount of customers, systems that can be and should be tested using test automation. And one more thing. With test automation in place, one could refactor the system on the test using the Beam. This is, of course, I heard of this a million of times, especially people pushing TDD. Like, if we have test automation in place and we have 100% coverage, we could potentially rewrite this in whatever technology we like, at any point we like. I've never seen it happen, but I hear people talking about it. I hear people swapping different technologies, not because of they have test coverage, but more because some new engineering manager, CTO comes along and says, we should use this technology instead of that technology. Yeah, but this is a potential way of doing stuff, actually. Thanks. That was it. Thank you, everyone.
Any questions about testing?
No?
How did you come to give this talk? What inspired you? What was the core formative?
Sorry?
What was the formative thought to every talk has a beginning? What encouraged you?
A, test is undervalued.
Yeah.
B, as I've used it myself, Beam and Common Test, to test stuff, I think it's very good to test with that.
Do you have an opinion on quick check or proper? And
yes, you should use it when you can. Quick check and proper. Quick check I've seen implemented. I've been part of implementing it. It's not super easy to implement and use, but it's extremely powerful, especially if you have protocol testing or if you have multiple inputs, outputs, and you just need to verify that we can handle whatever comes, especially if you have an open API of some kind where customers or whomever can dump stuff on you. Quick check is a good way to make sure that you are covered in all scenarios. Yeah.
Covering all the bases. Yeah.
So I do Elixir, so I've never used Common Test. I assume it's the sort of regular testing framework for Erlang.
Yes, and for Elixir also.
Huh.
Yeah.
Have you tried anything like this with EXUnit?
No. No, XUnit, no, I haven't. But you can use that, Common Test and XUnit, yes.
Huh?
I haven't used XUnit. I would say like a lot, when we talk about tests, usually with developers, people end up talking about unit tests, and you need unit tests. But if you look at the complete scope, and especially if you look at what, like if from an end user perspective, they tend to not care if you've unit tested, but if you're end-to-end tested. Yeah.
And EXUnit doesn't care if you're actually doing unit tests or something else.
Yeah.
Ideally. Well, thank you very much, Magnus.
Yeah, thanks. Thank you.